So with that said, Howard and I had a discussion some time ago, and really we were focused on the kind of discussion around incorporating expert systems into a program like Unity, and how to kind of build that functionality into a 3D platform. How we organized our talk today is kind of, let's build the app together. What would it take to build something like this? So we're going to go through kind of the stages of project design. I'll start out by talking about kind of the fundamental project planning aspects. What goes into a Unity scene. Some of you may be well familiar with it. If some of you haven't used a program like Unity before, I hope that you pick something up, and we'll also go through some of the 3D tools that we have access to, as well as the 3D methods that we have, and maybe give some context on when a particular tool might be valuable for the job that you're wanting to do. So here's our agenda. Basically just summarized what I said here. So we can move to the next one. So just a brief about us. We're from a company called Augmented Info Systems. We founded it together. We do work at Digital Worlds Institute as adjunct professors, helping out with the classes over there. But primarily, we work at our company, and we also do some additional work on the side. Our primary focus is on educational technology. And we felt that this is really relevant, right? Because that's the whole premise behind the expert system. And really, what we want to talk about is there's a great deal of knowledge contained at IFAS. And, how do you translate that into something that reaches the public through extended reality? There's a whole bunch of different methodologies that are already used. But obviously, VR and AR, they present some interesting possibilities that may not be fully tapped yet. And as Howard mentioned, yes, we did collaborate with the National Park Service on their Public Lands Day, and we modeled a public space out in Micanopy and kind of gave some high-level design ideas on how to do it. But we're going to talk a bit more in depth about building just an application.
Excuse me, what does AI stand for again?
Oh, that's Augmented Info Systems. That's our company.
I want to make sure I have it right.
Oh, thanks. We also have a card. So if you'd like to get in touch afterwards, here we'd be more than happy to give you contact details. Anyways, so let's imagine a plant picker. Here's our example application. And how are we going to build plant picker? So here's the scenario. You, an expert, you want to create an app that helps suburban residents select appropriate plants for home landscaping. Much like an expert system, kind of like a chatbot in a way, probably a somewhat similar decision-making process on the back end. How do you do it in VR? Let's say that you want to use Unity in VR. Okay, so when you start breaking down what a VR project is, what a project in Unity is, there are artistic and mechanical properties. That's really the starting point, is to break down what are the art assets that I need and what are the functionalities that I'm going to build. Probably the most important thing in a practical sense while you're developing an application, in our view, is to know when to say no and prevent scope creep, because you can end up with a huge unbuildable application. So we start out with a very delineated approach to the app development, really kind of nail down exactly what you're going to build and try to build it. So for instance, your artistic assets in a VR scene would be typically 3D models, your lighting, Any animations, these might include plant growth animations as we were discussing, as well as any special effects. Maybe you want to represent how the weather is, or, maybe specific circumstances like how could an environment hold up in the face of a hurricane or something like that. And you can accomplish pretty complex physics simulations in Unity. We'll touch on that at the end. So, you can kind of let your imagination run wild in some sense, but those are the artistic. And then, your mechanical, as I mentioned, you may have physics simulations, hydrological systems, your actual plant growth models, and anything else related to your code assets. There's a lot of other things that go into it. Your code assets, obviously, that would be like your expert system. What are the rules that you're going to apply? And in Unity, you would do this by developing those rules into a sort of like a script in C#, maybe some kind of manager that incorporates your information. So what would we need for a plant picker? Like, what would you need to do this? Well, beyond the expert knowledge, you're going to have to get a bunch of 3D models of plants. You're going to need the domestic built environments. How do you model the terrain that the plants are going to be on? That can be kind of an open question. If you're working with a random suburban resident, let's say we just pick somebody from the Gainesville area, how are you going to get their house and their kind of plot of land into Unity, into your 3D scene? Typically, you might think a more abstract representation might work. You might work with just an example of the rough size of a house on a plot of land, or you could go very detailed. We'll go on for that in a second. You'll have your lighting. And again, if maybe you want to model your rain, etc. Your mechanical elements, well, the user needs to get around. You're going to have to make something for the user to actually be able to interact with the 3D models. That would be your user interface, selecting and placing the plants. And then here is like your expert system. How do you inform the user when a plant is well placed? You're going to have to develop in Unity kind of a system of rules that considers, hey, where is the plant placed in this environment? You can develop all sorts of tools that can consider perhaps the distance from other structures, other plants, the lighting conditions, etc. So you can definitely do those things through C#. And then maybe you even want a character that sort of talks the user through what they're doing, gives them some kind of base info about how to interact with the scene, the plants, etc.
And just to add to that, specifically for VR, you really need to consider normal movements and how the user can interact with the VR experience in the most natural way. Because as a developer, sometimes we develop an app and then we give it to the user and the user just does not know how to use it. Even though we think, oh, it's just moving the joystick or it's just selecting this button. But then you give it to somebody that never used VR and they just don't know how to start. So we really focus on add-in movements that are just grabbing something, throwing something, or just talking so that it's easy for anybody to use.
So now here's a note on realism. And this is kind of an important note because, Howard, as you earlier mentioned, there is a potentially infinite amount of information that you could include in a simulation like this. It's very true that plant meshes are quite literally, frequently a surface mesh with a texture on it. We work with those all the time. So when you think about what the application needs, like for instance, plant picker in the expert system, right? When you're modeling an environment like this, probably the rules of the expert system are where most of your time and effort would be in developing. You could develop very detailed models of the plants, if the application called for it, but frequently you need to trim down the amount of information that is included in the app at some point. Otherwise, you'll be developing forever.
Just like me.
Right. And so, an application that's designed for scientific research, you may need highly physically accurate models. Those are out there, and we'll talk about some of the methods that you can use to develop them. An app designed for consumers may not need that level of detail. So let's go to the next one. So, here's generally how I think of this. This is just a kind of a broad level overview, but I don't want it to get too abstract. This is important because you need to consider what level of complexity to incorporate in your app. If we consider at one end of the spectrum, like here's what, your base mesh, right? Some apps might just call for that. Where, you can develop all the way up to interactive photogrammetric models that are exact scientific replicas, roughly, of plants that exist in the real world somewhere. And the same with physics, right? Your physics might consist of just like gravity. If you drop a plant, it falls. Or you can build very complex physics systems that model, the behavior of water and fluids in the scene, the, behavior of wind, etc. So, you have to decide, where am I going to go with this? What is the most important thing to tell the user? In my mind, this plant picker app is probably closer towards this end because it's, it's the purpose of the app in my mind would probably just be to help a regular homeowner place a plant. So that's what I think. And never forget that as computer science in general, but also with virtual reality development, complexity versus performance is a huge trade-off. So the closer you get to this end, especially on the essentially cell phone of a VR device, it will slow down significantly.
Loading models take forever.
Yeah, really.
That would, when it slows down, it can cause, at least for me, a really serious motion sickness. I work with VR all the time, every day, and I still get motion sick every time I use it, depending on the app. If the app is slow, I will probably remove it immediately.
I'm curious, do you guys also do AR? Have you worked with AR?
Yeah, we work
with VR is your bread and butter, is that the story?
I don't necessarily know. Ines has done a lot of work with AR, with large, even state level governments out in Texas, etc.
Nice.
So our startup is new. We recently started.
Yeah, I'm happy to help you guys think this through. The benefit of AR is that a lot of the environment, you don't have to model it, you just use the environment as it is. So, and the problems of motion that you describe, of needing to, describe motion for the user, you just walk around,
That makes so much sense.
Yeah.
You're right.
It's a real neat chopping off a bunch of stuff from VR. AR is sort of more minimal. Think about it.
It could be that Plant Picker might be better as an AR app.
I think so.
Yeah.
I was going to say as well, the Apple Vision Pro, which is coming out, supply chains say this is happening. It's coming out in March of next year. Is designed to be a device that you can seamlessly go from really a true VR experience, as you guys are describing, as Howard described, into something where you just press a button and then it starts to become, you're back alive again. But the ability to render graphics is preserved. And I think that's the thing that both of these things have in common, is rendering graphics. Anyways, I wanted to make this.
Oh yeah, of course. And specifically, so for instance, we can make a short diversion here. Perhaps this is a great place where AI might fit in, because if you were developing a rules-based expert system in VR, you would imagine that the rules would take into consideration the models, the 3D models that are present in the scene. With an AR system, if you were using the real world, you would need some manner of identifying what's in the environment, and then sort of probably some things like surface identification to know, for instance, where the ground is and the relative distances involved. So that would be very interesting.
Exactly.
Yeah.
Well, I'm going to talk about that next, so this is perfect.
Oh, perfect.
Yes. But no, this is fantastic. And I'm learning a lot. I think this is really useful what you guys are saying about, you know, understand if your requirement demands photorealism, it might not. And you get a lot of value, as he's saying, performance and, you know, just in being able to get the job done.
That's right.
I think it's, you guys are clearly like,
to make and ship the app,
yes,
and get it into somebody's hands.
That's called
very important. No, yeah.
Great stuff. Yeah.
Yeah,
So,
that feature creep is a really big thing. The more you work with the clients, the more stuff they ask for, and then that doesn't usually end.
Yeah.
The app, instead of taking a couple months, it will end up taking a year.
5 years.
Yeah.
so, and one last note that I'll make is, you know, let's imagine an application which is both, you know, at the very high end of visual and physical complexity, right? You know, really what this suggests is a digital twin, so to speak, of the world. You know, I mean, it's just kind of recreating the real world in almost all of its facets in a digital space. And that is a very exciting possibility. And I know that a lot of work is being done in that space. I think, you know, as you mentioned, typically from a commercial standpoint, and trying to get things into the hands of the public, you know, we tend to think of what can we strip out? You know, if the app does not call for a perfect replica of the real world, then, you know, we ought not to develop it. But for a scientist, for instance, or to run on, for instance, maybe the hypergator, you know what I mean? A very complex physical and realistic simulation of the world, essentially, like outside to in Unity, I think presents some very interesting possibilities, but maybe not for Plant Picker, I don't know.
So we kind of already talked about this, and I wanted, I guess, in my opinion, what differs VR from AR is that in VR, you can get into a whole new world. And it does not have to look like the world we live in, because we're already there. So when you get into VR, you can create whatever you want, be in whatever environment you get, and you can be inside Nintendo World or Firewatch or all these beautiful games. I'm a big fan of stylized environments, and as Austin said, when you're designing a scientific application, for instance, like cataloging plants and all of that, a high degree of scientific accuracy is necessary. But in other applications where you're just trying to give something to a client or a consumer, a lot of the popular most successful games like Pokemon, Firewatch, Zelda, Persona 5, my personal favorite, and Overcooked, yeah, they don't focus on being very accurate. They just want to create something new for you to experience. So I know for us, we always get asked by clients to make something that is very accurate. They always want everything to be realistic, which is good, but you don't always need that for every single app, because making stylized words is also good, and some people prefer that.
Yeah, it's typically where the user's frame of reference is. And I think, you know, one important thing to note about it is that, you know, regular users may be using your app that really don't know a great deal about, you know, agriculture or anything like that, and might not know it even if it was right in front of them. You know what I mean? For instance, they may not be able to accurately identify some species of plant is not exactly how it might look in the real world. But if the purpose of your application is to show where to place the plant, for instance, then, drawing them in and engaging them with, not necessarily distracting or untrue representation of the world, but some degree of stylization to make it beautiful can be really valuable for helping users engage with that application.
I like that.
So after you already got your app idea and you considered what sort of art direction and how much realism you want to be in your app, and I think for Austin and I, we really want to set that in the beginning and then stick to the plan and not change it. Because once you start changing that later, after you already started building the app, it takes forever. So you really need, you make a plan, you set all your points, and then you stick to it. I think that's the most important part. But after that, you need to consider the tool sets. And here, I'm going to talk about the 3D tools that we use. So talking about our example of plant picker, the plant picker app, we need to design some plants for our environment. What we usually use is Blender and Maya, and they're the most popular 3D modeling tools in the industry right now. And they let you create 3D objects from the ground up. So you can start from tiny cubes and then whatever shape you start with, and then you can build it into a plant. So these tools, they are not specialized for texturing, but they also allow you to put basic texture. If you want to add complicated texture, we can use tools like Substance Painter. And I would say the main difference between Blender and Maya is that Blender is open source and very user-friendly, and Maya lets you do more advanced features, but it is very expensive.
Sorry, I don't know how we're doing on time.
I think we're great.
We're getting the clock. No,
We had till 5, and folks, we're gonna take a break after this.
Okay.
Yeah, and the next part is photogrammetry, and it's one of the most user reality capture and Agisoft. These are one of the most powerful tools to create very realistic plant models. This will get you the most accuracy possible, but it's also, it requires a lot of cameras and it requires powerful computers to run, and it can be very performance heavy, but it definitely gives you really good models. And also, I don't know if it's easier, but you can definitely create a plant really quickly and then clean it instead of modeling it all the way up from scratch. And then SpeedTree, Austin is more familiar.
Oh yeah, SpeedTree is a really great tool for creating realistic trees. This is something that we would typically use in a more detailed nature scene. You can control the structure, etc. The only thing is that it's going to be dependent on what you can do with it. So for instance, let's say you were to model a Florida oak tree. SpeedTree would allow you to make that tree as realistic as you can make it. If you make a mistake with the representation, it doesn't know what a Florida oak should look like. So I know, for instance, your reference to L systems and machine learning, like building out specific, algorithms to build, very particular species of plant, that is not a part of SpeedTree. So that requires, the user has to bring their knowledge into the platform to make it look appropriate. However, it is a very powerful tool to quickly model accurate looking trees, and you can build photogrammetry features into it, which is great.
And SpeedTree also supports the dynamic wind and growth animation. So this is where you can use it to have a tree slowly grow or a flower slowly bloom, right? I'm not very familiar with how to do it. I think it's very hard, but yeah, Austin uses that.
Is it species specific? Does it have for like a small set of species?
No, so you have to build, so what Speed Tree allows you to do is build a tree from scratch. So, it breaks a tree down into components. It breaks it down into, spleens like this, the body of the tree. It breaks it down into leaf patterns, twigs, etc., that you can build multiple layers of complexity. But it relies on you.
How about the textures? Are you projecting your own photos and stuff onto it?
So yeah, you bring your own textures into it, and that's where you can incorporate photogrammetric assets, including with the leaves, etc. So long as you can make the physical structure how it ought to look, then you can bring in real world textures, and you can achieve some amazing results.
It's impressive for sure. I could see us combining machine learning with this basically. Because this looks like a great sort of user interface, and it seems like it's highly constrained and all those benefits. Also, some stuff about.
I'm expecting all these things to work together.
I mean, it's more of just an idea. Like, there's many things to do. So.
To make one tree, what's the labor like associated? Like hours, week?
So it depends on your skill set. If you are familiar with the software, you can make a tree in an afternoon, Obviously getting to be proficient with the software is its own challenge, and it can be challenging. But that's with everything, it is an artistic skill set. So, your knowledge of trees or plants or whatever it is that you're modeling is going to inform what you do, but it doesn't mean you'll automatically right off the bat be able to create beautiful looking trees, because you need to be familiar with the interface. But I would say it's an industry standard tool. Everybody uses it. There are a lot of resources on it. You definitely can. This is not like some sort of obscure, difficult to learn program. There's a lot of information about how to use it.
So after you get your models, you have all your 3D models, they're textured. Now we need to move on to the game engine where we'll put them all together. Unity is the main game engine that we use. And for this plant picker app, what we will do in Unity is that we'll get all these 3D models. We'll start composing them next to each other. We'll make a beautiful garden. And then you can add your player and start adding the functionality. With Unity, we code in C#. So you can code the interaction with the environment. If you pick a flower, what happens? You can also gamify it. So if you pick the wrong flower, maybe you're losing points or gaining points. So all of that happens inside of the game engine. And right now, the leading game engines are Unity and Unreal. We are more familiar with Unity. However, they're both really good software that everybody is using now, and they come with a lot of plugin that makes development really easy. So for the Unity, they have the Unity Asset Store. You can go in there. They will have so many different kinds of plants. So they will have packages for the most realistic plants, and they also have packages for low quality models, and you can just import those into your project and start making that happen. And then I just put a quick comparison between the two engines here, because I think a lot of people, before they get into creating the app, they could spend a lot of time deciding, oh, what should I use, Unity or Unreal? I think at this point, they both grew and evolved so much that they're very similar. They will lead you to the same result in the end. However, Unity is known to be more user-friendly, and it's used by indie developers, and they also have a really extensive documentation and supportive community. While Unreal will give you more advanced graphics and rendering capabilities, and they're used by big AAA studios. So if, as you can see in this picture, this is just a garden. It looks beautiful, but this one has all those beautiful lights, and yeah, Unreal will help you achieve that faster.
Quick question is, do you know for the scripting languages, so you mentioned C# for Unity, is do you know if any of them have a Python interface?
I don't think so. Yeah, I think I'm not sure. The main one that I use with Unity is C#,
Okay.
and then I know that for Unreal it's C++, which in my opinion is harder than C#. So, but Unreal, they have visual scripting in it, so it can really let you prototype very quickly.
This software.
They're both free,
Both free.
unless you start making a lot of money.
Yeah.
Then they want to release. But yeah, I mean, you have to make, for instance, Unity, I think you have to make more than 100,000 for them to even start taking a little money.
Yeah, if you want to, if you start making money and if you want to publish your apps, then you need to get Unity Pro. And at that point, I do use Unity Pro. I think it's 450 per user every month. So if yeah, so it can get expensive once you start making a lot of money, but usually that's the yeah.
I'm just curious. I don't know if anybody else remembers this, but Unreal started out as a video game.
Oh yeah,
Right.
It was built in the Unreal Engine.
Yeah,
Yeah.
and it was the Unreal Engine. Where did Unity come from?
Unity was initially, I think it came out of Apple.
Oh, really?
Yeah, it was, I think, demoed at initially like that Apple Developers Conference, probably maybe something like 20 years ago. Now it's in the.
I've heard that the what is it, Vision OS, which is it's like their iOS for augmented reality. That's documentation's online now. You can start to mess with it. I'm gonna be messing with it early in a month. And basically, I think they have a Unity scripting. Like,
oh yeah.
Anything you build in Unity is instantly be ported into the AR.
Yeah,
Apple Vision.
I do think that overall Unity is better for AR and VR for XR because it's really tailored to it in so many ways. And the Vision Pro, I'm developing an AR app right now, and right now it's developed for phones and we're going to add it to the HoloLens. But yeah, so are you familiar with TestFlight? Yeah, yeah. So TestFlight is the testing platform for Apple. So when I push my AR app to it, so that you can test it on your phone or your iPad, I can already see an option to test it on Vision Pro without having to modify my code at all, which I think is amazing. So the product is not even.
It's just like fun. We're trying to create collaborations and build movements here. I think I could absolutely see us putting together a joint application to Apple's like developer labs, and it would be a good excuse to go to like New York or Tokyo or something. And then we would show up and they would basically coach us and give us free access to the Vision Pro device.
That would be awesome.
As in, like, they're already doing it with developers. And I've just been waiting to have an app, but you guys have an app. And yeah, we've got the recommender system, and Plant Picker could become a real thing.
Yeah, we should make Plant Picker. But anyways, the short story of it is Unity is where the expert system is going to live. Your expert system, whatever your rules are going to be built into C#, and then that code can execute in Unity. So that will make it, interactable with those plane models. Anyways, I think we're running over here, so I'll just go really quickly. You can do a lot of physics simulations. You can do basic ones. You can do really complex fluid simulation with like NVIDIA and all this through particle-based systems. So It depends what you need. If you think your users need it, incorporate it. If you don't, then it's not gonna take away from the app if the focus is not on physics. And then
I just added this just to show it quickly. So my focus is more on the back end. So I mostly write code. This is really helpful to me because I can use procedural word generation just to create an entire city or just create an entire landscape with just one button. And then I can modify it and I can just bring it up to life. Yeah. So I just wanted to show this, which yeah, it is. This is one of my favorite. Yeah, this one is one of my favorite because it's really one click. You set the layout and you say generate plan, and then you click build city, and you have a city.
Generate city with lots of gardens.
oh yeah.
Yeah, this one is called the Fantastic City Generator, and the one on the right is Gaia, and this Gaia is very popular. You can create a whole world in a second.
So that's it. I think that's it for Plan Picker. Thanks so much for your attention.